Bismillahirrahmanirrahim. My name is Shawali. Today I want to show you how to analyze the data and clean the nice data. I already download the data from the Kaggle, www.kaggle.com, and our data is about mental health in the tech survey. I already downloaded it here, and also I have in my PC. But now let me show how you do that. First, we go to add you can put the database or my computer. I already put it in my computer, and it's my desktop. And we go to find this is my data, and we put next, and we put the header we needed and start from 1. And this is we put next, and we see the age is integer and the gender is polynomial, country all is polynomial, and then we put next, and here is some the self-applied is null, and this is also have some missing values, so here is null. We have next. Okay, let's see. We go to the statistic. Okay, we don't have any missing value, and here is the age is a problem. C is minimum minus should not like that. This also a problem. We have to fix it, and go to design. Then we put the file data. I put the data, and I want to replace the data, the attributes, and let's check here. This one here and this here. Okay, I want to replace the null in the which was the null. The null was inside the self-employed. Okay, go design, put in null. Okay, null, put the self-employed. Put because the self-employed have the name is more. Then no, we put the no because no is not the majority. Okay, then okay. Okay, run. This is we get the see here. Now we get the no, because why you put no? Because the most of the majority of the null no was existed in this table, in this self-employed, and this one also have the gender. It should be woman, and there is some missing value. Let me see. Okay, yes. Okay, let's go and do this one for woman. Go to my design. Okay, we did replace because we have 3 variable, because this was gender also woman, and the work interfere also was null value. Attribute, sorry, we also fix it, and the self employee. Now what we want to do, we want to it was because sometimes was more than never and often rare. We submit the null value with sometimes, and we go to here. Now we want to filter. Okay, filter. Okay, and the filter. Okay. We want to filter the age, age. Here age. We say if age is greater than 20, add entry, and also age is less than or equal to 60, and okay, and go and run. Okay, as you can let me see, the age is now fixed. Okay or no? Let's go to statistic. Yeah, see here now the age is okay, and now I have to do the generate data. Okay, go to right here, generate attributes. Come here and this one here. Okay. Now to generate the attribute. Get it no, treatment. Right. Name. Okay. If treatment. Okay. It's done if treatment equal to yes, and you have to fix it. Then you have to apply. Okay, apply. And it's done. Obvious error. Expression. Okay. Let's go to here. Expression. Okay, there's a spelling error here. Treat main. Okay, let's apply. Okay, now it's running. Okay. And let's see the statistic. It's all. Yeah, so everything is okay. Now see here also treatment. We have no, yes, all this 608, and yes is the most value 623, and the values yes 601, and this is okay.
Assalamu alaikum wa rahmatullahi wa barakatuh. I'm Muhammad Ramazan Sari. So we continue our presentation for the pre-processing of the data. So shall we leave my partner stop here from the generating attributes. So now I'm going to use the specific attributes. I'm going to use the specific attributes for the pre-processing. So I'm gonna use from the option select attributes. So this option is for specific attributes that I'm going to use for this project. So I'm gonna click here. It's you're gonna click on submit subsets, and then you select here. So this page shows me that which attributes that I'm going to use in my data set. So I'm just going to use age, the country is important, the gender for this data set, the benefits, family history, so the physical, investmental, self-employed if the person is employed, the treatment, how the treatment is, the wellness program, the work, and interfere. So these are the attributes that I'm going to use. So I'm just going to apply them and just run it. Okay, here we can see these attributes that we have using the specific attributes: gender, country, work interest, self-employed, all the attributes that I have used. So after this, we need to have a specific class for the attributes, and I'm going to use from the option set rules. This option gives me to make specific class, I mean from the attributes, so I need to make one of them as our class. So you just put it here. You disconnect this, you connect here, and okay, so from here we make treatment as our class. This says you should use a label, and then we run it. Okay, you can see if it becomes the class, then you can see the treatment. It becomes green color, so it's highlighted, so that means that this is our class.
Assalamu alaikum. Bismillahirrahmanirrahim. My name is Qadir Rahimi. I will continue with this, my friend, until this part. So I will go to the design part to design after this. So my friend just finished the set rule. I will continue with the validation to validate the data. Once you validate the data, we will search for the X validation. X validation. So we don't have X validation here. We just choose the cross validation, because the cross validation also works the same as X validation. So we drag and drop the cross validation here. We drag and drop the cross validation here. We connect this to this one, and then we measure these three. Okay. Once you measure this one, once you measure this, once you finish, once you finish the validation, so now it's time to go for clustering. For the clustering, we will search for the clustering here. So under the segmentation, we choose the key methods. When we choose the key methods, we drag it here and drop it here. So we just connect the XOR to the XOR to this one, and just measure the flow. Yes, thank you.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Ahmed Hijazi, and I will be continuing the project for my friends, and I will be doing the decision tree, and we will do that on the cross validation. So we should start. First of all, we should enter the cross validation menu, so we can do our process there. First of all, we need to add the decision tree. So simply we're just going to search here for tree, and we use that decision tree, drag and drop, and we connect the process so we can start our decision tree. We need to modify this, so we're going to use the gain ratio, and we're going to set our confidence to 0.5, and we're going to set our minimal gain for 0.05, like this. And then we have to add our model in the next one, so we are going to search for the apply model, and we just drag and drop in the other testing menu, and we just connect the pairs. And now, before everything is done, we need to add the most important part, which is the performance. So we just it's for classification. So performance classification, choose this one. So we drag and drop. So basically, the performance classification job is to do the accuracy for errors and precision, recalls, and all this stuff. So it's like an operator that used for statistical performance and evaluation for classifications and all this stuff. So we just connect the lab. Here. And now we are ready to start our testing. So we need to wait for the clustering to finish. That might take a moment. If you could just wait with us. Thank you. It's done. So this is the cluster model we go for the decision tree. And this is our decision tree. It's based on the family history. So the family history is the node, and it will make the decision. So it's based on the family history about the mental illness. If there is a mental illness, we have a part of the decision tree. If there is no family history for the mental illness, we have a different part. So I will quick explain about this. So if there is a family illness in the family history and the age is lower or equal than 52, that means there is work interfere. So their mental issues or their mental sickness interfere with their work and their work environment often and rarely and sometimes. So it happens there. As we can see, it happens often and it happens rarely, it happens sometimes with different ratios, but it happens. That's the most important thing. And also, if it does not interfere with work, that would be for the age, average age of 35, that will not interfere with the work environment. If we went to the other side of the family history, so if there is no any history for mental illness, so that means the work interfere will rarely happen or never if the age if the age average is 22, so it will not happen, as we can see most of the times. But if we consider the gender for more than 22 years old, so if the gender is female and they are more than 22 years old, so there will be work interfere with their mental illness, even though if they don't have any family history. If they don't have family history, but they have illness issues, so it will work interfere if they are 22 years old and above, and if they are female. If they are 20 years above and they are male and they are between the age of 45 and 22, so if they are more than 25, yes, there is still going to be interfere with work environment. If they are less than 45, there will be no work interfere, as we can see. So basically, this is our decision tree that we can later analyze and bring the insights about our data analysis. Thank you for watching.
I am Ahmad and I will be discussing about the clustering in this project. So here we have clustering. So I already ran the clustering. I just go to the result. So in the result, first go to description. We have 5 clusters, cluster 0, 1, 2, 3 and 4 in each cluster. So in cluster 0 there is 75 items, cluster 1 174 items, cluster 2 453 items, and cluster 3 193 items, and cluster 4 336 items. So the total number of items are 1231. So I go to the graph, and then the graph the majority are in cluster 2 and the minority is in cluster 0. So in the centroid table we have 5 clusters: cluster 0, cluster 1, cluster 2, cluster 3 and cluster 4. So for the first attribute, work interfere, all the cluster shows 3, which is in this question we have work interfere. If you have a mental health condition, do you feel that it interferes with your work? So here number 3 is equal to sometimes, which shows that almost all the respondents said that answered that they have the work interfere sometimes happen. So for the self-employed, for all the clusters, the value are 0. So in the question we can see that self-employed is are you self-employed? Here the attribute, the value of 0 shows that most of them answered that they are not self-employed. For the gender 0, 0, 1, 1, 1, it shows that cluster 0 and cluster 1 the majority are female, and for cluster 2, cluster 3 and cluster 4 majority are male. The age group in each cluster, or in cluster 0 the average age is 46, cluster 1 41, cluster 2 43, 34, cluster 3 25, and cluster 4 26. So family history is 0, 1, 1, 1 and 0. In this question, let's see the family history. Family history. Do you have a family history of mental illnesses? Here the 0 shows no, and the value 1 indicates yes. So the respondent whose age are 46, they said they don't have any family history in of mental illnesses. And for cluster 1, cluster 2 and cluster 3 they answered yes, and for cluster 4, which is the age, the average age is 26, answered no. So for benefits we also have 0, 1, 0, 0 and 1, that indicate 1 indicates yes, and 0 indicates no. So let's see the question. Here, benefit: do your employer provide mental health benefit? So here we can see that the cluster 0 respondent that their age are 46, average age of 46, so they answered yes, and for cluster 1, 2 and 3 they answered no, and for cluster 4 they also answered yes. So this is all for the clustering part of this project. So here also we can see the graph of this clustering. This one is the age, it shows the age and benefit, gender. So thanks for watching.